Hello, everyone. Good morning, good afternoon, good evening, wherever you are calling in from. Uh, Welcome to Mirantis Labs Tech Talks. We are here to dive into cloud native topics, use cases, tutorials, and many more to educate you all. I'm Avinash Desireddy, Senior Solutions Architect and Developer Advocate here at Mirantis. I'm joined by Karen Almog, Architect at k0s project, to talk about what is k0s, the use cases, how to get started with it, and we have an awesome demo at the end to quickly get started with k0s. With that, Karen, can you please introduce, tell our audience about yourself?
Yep. Yeah, I am, as Avinash said, I'm a software architect with the k0s dev team. I come from originally a DevOps background. I've been working as a DevOps engineer for many, many years. So you can say that I was a DevOps transition to dev. And I've been contributing to open source projects for many years, including k0s at the time. That were developed at Tectonic Kubernetes distribution that then later became OpenShift for. But that's about me. I'm here to talk about k0s and explain the benefits of k0s, why k0s could be beneficial to you, and what are the main strong points of k0s. So when we come to develop k0s, one of the main core target objects that we have is to keep it versatile, meaning to be a little less as unopinionated as possible. So to give you the Kubernetes experience with a vanilla Kubernetes distro upstream, Kubernetes distro, that means not forked. So we're not modifying Kubernetes itself, but we keep it as vanilla as possible so that you can run as any workload that you can possibly do and use it for whatever purpose that you see fit. One of the other objects that we have is to keep k0's security as a standing point, and that's where control plane isolation comes into place, and I will elaborate on that in the next slides. k0s is also OS independent. That means that all the components of the Kubernetes distro, or k0s distro actually, is already included, and it already includes all the dependencies. So theoretically, it can run on any Linux distribution. Of course, maybe if you have a very, very obscure Linux distribution with weird setup, then yeah, just open an issue and we'll see if we can fix it. But in general, all the Linux, the main core Linux distributions will be supported. So as I've explained, k0s is shipped as a single binary. And we also package Kubernetes inside this single binary. That also means that if there's any vulnerability, if there's any CVE that comes out that requires to be patched, we just patch it inside the Kubernetes, the k0's binary, and then we ship a new version. There's no connection between k0's upgrades and the operating system, because like I said, all the dependencies are already shipped inside k0s. So there's no operating system dependencies that need to be updated at this point. Everything is shipped inside one binary. So as I mentioned, k0s is a versatile distribution. So we try to ship it with, of course, the default components, but of course you can plug in whatever component that you can. By default, we use containerd as a runtime, but we also support Docker as a runtime with the Docker shim. As a CNI, as a networking, we use Kube router for certain scenarios, and we use Calico for other scenarios, which I'll go into in next slides. And we also ship k0s both with etcd and with kind or SQLite support. So k0s has multiple deployment options. The simplest option to deploy k0s is as a single node. We see this scenario as the developer workstation scenario. That means that if you're a developer, you want to run k0s, or you want to have any Kubernetes distribution running on your laptop fast, then k0s enables that with the -- single parameter. And in which case we will disable many of the components that will take a lot of memory or CPU and that are not relevant or needed in a single node setup. So that's why we also use kind or SQLite instead of, for example, etcd, which has a lot of overhead in terms of processing time. And we will also disable a lot of reconcilers that are usually needed for multi-node processes, like controller leader election and everything related to worker controller connectivity. Because in a single node, of course, that's not needed. You have one node that is also a controller and a worker. That is, however, not, let's say, the recommended way to run k0s. And I will go into that and explain that the recommended way to run k0s, especially if you run it in production, would be to have a dedicated controller, a control plane, and a worker plane, or it's also referred to as cluster plane. So in opposite to other Kubernetes distros, our controllers do not run any workload whatsoever. So they just control the cluster, but they don't have even kubelet running on them. So that means they don't run any pods. And that allows, first of all, a complete separation between the controller and the worker nodes. And it allows, for example, for a specific use case, for example, the Internet of Things use case. Because when we're talking about something like Internet of Things, we will have a host of workers that have very small footprints with related to CPU and memory, and they would not need the control plane components running on them. So in which case, sorry, the controller, like I said, the controller and the worker will be running on a different plane and will be completely separated. We also allow for high availability. With a small cluster, for example, we would have multiple control planes and a load balancer in front of them. And they will basically used with an etcd in order to let's say, etcd will be used as a key value store, sorry, to hold all the data. That is, of course, an opposite to SQLite, which is more of a single node database in that sense. I'm not going to go into high availability at this point because that's not the focus of this presentation. So as I explained, we can see here also another graph that shows what a k0s cluster would look like if we had high availability between the controller nodes with the load balancer and worker nodes that would run the apps and the workload. And these components are, of course, completely separated. So k0s come with multiple tools that allow a user to install k0s on a Linux host, upgrade, backup, restore, etc. We call this, we have the main tool, which is called k0s CTL. I can show you that in the demo, how it works. And that tool is then used in order to deploy k0s binary on all the hosts, connect to the host, configure them, basically create the k0s.yaml file and make sure that the connectivity between the controller and the worker is working, and also fetch the kube config so you can actually access the cluster. It also allows for air gap support, and I will also demo that. By air gap support, what I mean is, let's say you have workers that are in an environment without any internet connection. And without this internet connection, you won't be able to fetch the relevant images that are required in order to run k0s or Kubernetes actually, and you won't be able to download k0s binary from the release. So you can actually tell that to k0CTL that you want an air gap support, air gap installation, sorry, provide the binary, and as long as you have SSH connection to the host, k0CTL will handle everything. The minimum system requirements that we found with our tests, you can see in this table attached, and it can be even one virtual CPU for either controller worker or a single node, and as up to 1 GB of RAM for the memory. And it would work. Probably not as fast, but it will work. As for the architecture, we support all the standard architecture, which is x86 and AMD 64, but we also support ARM processes, which is mostly used by IoT devices. Now, show you a short demo. And I'll start with manual installation of k0s. So you can see how that would work. Everybody can see my screen, my terminal?
I can see it.
Okay, so I actually have a controller, or actually a server that is designated to be a controller on AWS with that IP. And I've installed something, a VM actually on my host, which will be the worker. So connect to the controller. So there's nothing running for k0s on the hosts, and there is no k0s distribution running or a binary even. So what I'm going to do is I'm going to use the quick start documentation. I'm just going to copy here this command, which will download the k0s binary. I'm going to do it as well on the worker, because that's what you need. You have to have, of course, the k0s binary on all the hosts. Okay, so I have here k0s on the host, and that allows me to start by installing k0s. And what this would do is this would install a service for k0s, and I'm basically saying, please install a controller. And we can see here the system D service that has been installed as a result, that was installed as a result of this command. And I can start this. So I'm using the default, basically the absolute default setup possible. So that is simply a controller without any worker. So it's starting. And it's applying everything that's required in order to start the controller. So it's reconciling the controller components. So the connectivity agent, the autopilot, and other components that we have already built in. In the meantime, we can start, let's see if it works actually. So before we go ahead with installing the worker, I'll explain a little bit of how the worker connects to the controller. So in order for the worker to connect to the controller, it needs a token. So I'm going to generate a token from the controller. So I have the token here, and I can copy it to the worker. So we have here same version of k0s. And I'm going to ask them k0s to install a worker. So same as with the worker, we can now start the service. Okay. So I already found a problem with my setup. And the reason being is that I forgot, let's see. I forgot that my controller is operating with an external IP. So the token was generated with the wrong configuration, and it's attempting to connect to the internal IP of the controller, which of course it cannot do because they are both on the different networks. So what I would do is I would create a k0s YAML file. So it created the k0s YAML file with the API with the address, but with the internal address. The same here. YAML. And I'm adding an entrance here. And basically telling my controller that you're running with an external address. Everything here can stay as is, which is the default time. I'm going to tell it to use the configuration which I just had. And we can see in the configuration file that now it knows to use the configuration that I told it to use. Can make sure to see that it actually works by basically encrypting, decrypting the token and making sure that the configuration we have is the one that we want. If I'll go into the worker, let's see if I can see any containers. And I already start to see some kubelet running and a container shim running. I'm not gonna go into the kubelet and everything, but just to show you the process of running k0s manually, just so you can see the process of what it's done when we do it manually. I'm gonna kill the cluster right now. We see already container shims are going up. That's all the containers required in order to run the cluster. And I'm gonna kill everything so I can show you how everything that I just did is done automatically with k0s. So let's do that. Stop k0s on both worker and controller. I want to reset. Reset basically cleans every trace of k0s from the machine. Okay, let's see if any processes are still remaining. None. Okay, so I'm now on my own laptop, and I've have k0s already running or installed actually. And I've already created in advance a k0s file. So that's the configuration for k0s, and it includes the following. It basically includes the name of the cluster, the IP of our controller that you remember from the configuration I showed you before, the key path to be used, and I'm also using an air gap image, and the IP for the the IP for the worker, the key path for the worker. I'm asking it, please upload the binary so I don't have to download it directly to the worker, so do it automatically. And I have the external address configuration entry that I showed you before. So this is how I would apply everything with a k0s. So that's the command. I'm just going to run that. So it already detects the controller. It detects the operating system. It connects to the worker, does the same. And it's starting to deploy. It's already deployed the k0s binary, and it's also deploying the image bundle. And now it's uploading the k0s binary to the worker. For the controller, it's downloading it directly from the internet, from our GitHub release page, because we assume the controller already has internet connection. Okay, at which point what it's doing is it's starting to configure k0s, and it's initializing the cluster. By initializing the cluster, as you can see, it's generating the token that I've done before. It's writing the join token into the controller, and it's starting the services. Now we're just waiting for the node to become ready. And at this point, we usually already have a kube config. So we already have a kube config. So I just dump that into my default kube config. And let's see if we can see anything running already on the cluster. Okay, starting to launch the containers that are now starting to be created. And I mean, I can refresh, but it'll take maybe a couple of minutes before the cluster is up and running. And it already got a success signal and telling me that I can use the kube config. But of course, the kube config was already working because the controller was already up. What we're doing right now is we're just waiting for all the pods to be successfully scheduled on the worker. And as I mentioned, my worker is running on my laptop on a private IP, and there's no direct connectivity between the controller and the worker, meaning the controller cannot actually connect directly to the worker. The worker can connect to the controller, but not the other way around. And that's unlike most distros that require bidirectional connectivity between the worker and the controller. And I'm not going to get into this, but basically the reason why this is possible is because we're using a piece of software called connectivity. And that is one of the, I would say, the strong points of k0s. That's it. That's the end of the demo. So I'm going to now transfer it back to Avinash. And yeah, any questions?
There's one question in the chat, Karen. So does k0 need any licensing to use?
No, it's completely free. It's completely free, available to use right now. You can just download it. It's a complete open source, as well as k0s CTL.
Thank you. And a couple of other questions, mainly from me. So can we say k0s CTL is similar to Kube Admin to deploy an open source Kubernetes distribution? And once the cluster is deployed, the functionality is same with kubectl, regardless of it's a k0s cluster or a upstream Kubernetes cluster.
I'm not sure I understood the full question, but yes, in a way, k0CTL is similar to Kube Admin in the sense that it's used to deploy the cluster. Once the cluster is deployed, you use kubectl in order to basically manage the cluster, same as any cluster. And when you want to remove everything, you just use k0CTL reset. Now, basically k0CTL, I would say, is a wrapper for k0s. So everything that is done with k0CTL can be done with just k0s. Of course, you would just require more manual steps.
Understood. So just to make sure I understand it, so k0s CTL helps to manage the cluster, and when it comes to the application deployment, we come back to kubectl to manage all our applications.
Yes.
That's neat. Okay. And one other quick thing, I think I got it, but I just wanted to confirm. So when we deploy when we are deploying the cluster using k0s utility, it is deploying our container runtime and all the respective components on the cluster.
Yes, I can show you kind of how it looks. So I'm logging into the controller. And so everything will be in the k0s, varlib k0s directory, and you would have here a binary distribution, a bin directory. So k0s is one binary, but when it first boots, it basically extracts all the binaries that are required for its operation. So all of this is actually packaged into one single binary. Let's say if I deleted this and I relaunched k0s, it will basically go to the bin directory and see if any binary is missing, and it will extract it again.
Understood. That's nice. And in the cluster that you deployed, will you able to show us like by deploying a quick application, like a quick deployment or a pod? That will be nice.
Yeah, I think I have. So, let's see if I have it in my memory, because yeah, you know what? Let's go to the Nginx. Let's see if we can deploy this. All right. So yeah, it's now starting to create the Nginx. And one pod is already up. It doesn't include, I think, the services, etc., just the container port. So it's not like it's gonna, I'm gonna be able to connect, I think. But yeah, that was just to show you how it works.
Yep,
And
that
it's
helps.
pretty
It
fast.
just, yep, that's nice. So everything that we are doing with Kubernetes, we don't have to relearn like additional concepts to work with k0s or anything. It's just nice, straight and easy approach to start deploying applications on k0s.
Yeah, it's really important for me to stress that k0s is straight out vanilla Kubernetes, so you will be able to use it like any other Kubernetes distro. You can deploy it both on your own laptop or like I did on remote hosts, and you will be able to get it working in no time. And yeah, we're not using any forked Kubernetes with weird settings or anything. It's as unopinionated as can be.
Understood. Thank you. I think that's all the questions I have, and couple of, I think we also have. Can you tell us like where we can use K0 as? Like, is it just limited to like on Linux distributions, or does it support Windows or Mac? What are the different
Um,
environments that we can use K0 as?
yeah, so we have tested k0s mainly on Linux machines and ARM machines. So ARM machines, we've tested it on Raspberry Pis, but that's both for controller and worker. We support the workers on Windows machines, but not the controllers, because the CNI part of the controllers, for example, Calico, because if you're using the only CNI that works properly on Windows hosts is Calico, and in that and yeah, it just will not run on directly on Windows hosts. So controllers always have to be Linux or ARM. Workers can be Windows. Yeah, but it's a very experimental support at the moment. We support it, but we haven't seen a lot of traction from the community. It doesn't look like the community is very interested in worker nodes on Windows at the moment.
Understood. Yep. Thanks for those details. And one other thing. Yeah, one other thing I wanted to highlight is in order to like start using k0s, uh, instead of like spinning all these VMs or like having an infrastructure, a user can quickly get started with Docker Desktop Lens extension, Docker
Mhm.
Desktop Lens Kubernetes extension, where you can have a quick, lightweight Kubernetes environment on your Docker desktop environment and quickly deploy the applications. So feel free to check it out. Uh, it's quick and easy to deploy with click of a button.
Yeah, that's right. And I just want to refer to a couple of questions that I saw here in the chat. So I saw someone asking if k0s installs Calico, and the answer yes. It it depends on by default we use Kube router as the CNI, but you can enable Calico with k0s.yaml configuration. So it's basically just a question of Calico. Yeah, under networking, you just switch on the variable, just say true, and it will know to use Calico and extract Calico and deploy it. As for, like I mentioned, as for Windows workers, we don't have currently, or we haven't heard from anyone actually running Windows worker at the moment in prod. I encourage you to do that, and please open an issue if you run into a problem. We would love to, to hear from users' experience to see how well or maybe unwell this is working. We have no idea.
And just a quick note, Mirantis is actually hiring. We do have several positions. Please do check out the careers portal if you would like to join our team Mirantis and work on these awesome open source projects and then our exciting and our enterprise customers. And these are the upcoming sessions. Next Tuesday, we have a session from Kamal Bhaskar, who is a solutions architect, and he is going to talk about container image security, what it is, and how to remediate. And the following week, I will be presenting a topic on authentication and authorization in Kubernetes, where I will be deep diving into what are the authentication mechanisms, authorization mechanisms, and uh, how different cloud providers or like how different distributions of Kubernetes makes use of these models to secure your Kubernetes environments. With that, thank you everyone for joining us today, and thank you, Karen, for walking us through for sharing the information about k0s and how it helps. Uh, and with that, thank you so much, everyone. Have a good rest of your day. Thank you.
Thank you.